Comparing fractions. So if you look at example 1, it says which fraction is greater, this one or this one. If you had a calculator, the best way to do it is to turn it into a decimal and just look at the decimal value, right? It's pretty easy to tell which decimal is the bigger decimal because it's just ordering out numbers. However, with fractions, when we don't have a calculator, we need some sort of strategy to figure out which one of those fractions is the larger number. I have 2 strategies that I'm going to offer you. I think the second one is probably the more efficient way of doing it, but the first one gives you probably a better understanding of the comparison of the numbers. So it's kind of up to you on which method you want to do. Method 1. If I wanted to compare those 2 fractions, what I would do is try to make it so that the denominators are the same. Right? We call that having a common denominator. To get a common denominator, you want to think of what 3 could multiply to become. It's like skip counting, right? So 3, 6, 9, 12, 15, 18, 21, 24, and so on and so forth. I could just keep going up by 3s. Those are all the multiples of 3. I can do the same thing for 7. So if I counted by 7s or multiplied by 7s, I get 7, 14, 21, 28, 35, and so on and so forth. Your goal is to find a common thing that they could both multiply to become. In this case, they both could multiply to become 21. If I wanted 3 to become 21, I would have to multiply by, this would be by 2, by 3, by 4, by 5, by 6, by 7. If I multiply by 7, 3 would become 21. If I wanted 7 to become 21, I'd multiply by 2, by 3. We've done a lot of multiplying to get common denominators in the last few days, so it shouldn't be too earth-shattering. Okay, 2. Then convert your fraction to have that common denominator. What you do is you multiply the top and the bottom by the same number. Right? What you do to the bottom, you do to the top. So our first fraction of 2 over 3, we're going to multiply it by 7. If I do that, that gives me 14 over 21. If I look at my other fraction and I want to make the denominator 21, I would multiply by 3, like I had talked about. And that gives me, for a 12 over 21. The reason this is useful is now I have 2 fractions with the same denominator. It's easy to compare which one's bigger. For instance, if I had 1/2 and 5 halves, I know 5 halves would be bigger. In this case, I have 14 21ths and 12 21ths. Which one would be bigger? Yeah. And we represent that with that inequality sign. That's the greater than sign. So that means 14 over 21 is greater than 12 over 21. That means we can conclude that 2 over 3 must be greater than 4 over 7. Because when we got them common denominators, it was bigger than the other one. That's honestly probably the best way to do it because it gives you a good understanding of why it's bigger, and it gives you a way to compare how much bigger it is. It was 2 21ths bigger, not a lot. The second method for comparing fractions is probably a little faster, probably a little easier, but doesn't give you quite as good as an understanding of what's going on. Method 2. To figure out which fraction's bigger, if you just take the denominators and you figure it out that you cross multiply. So I'm going to take that 3 and I'm going to multiply by 4. And I'm going to take that 7, I'm going to multiply by 2. And all you have to do is the numerators, just that cross multiply it, and figure out what your 2 new numerators would be. So for instance, 2 times 7 becomes 14. 3 times 4 becomes 12. And all you need to do is figure out which number is bigger, 14 or 12. 14 is the bigger number. That means this fraction was the bigger fraction. So you don't actually even have to get a common denominator. You just have to cross multiply and compare the numerators and see which one gets bigger. Either way, we came out with 14. Sorry. Didn't want to use that color. I got that 14 is greater than 12. That means 2 over 3 is greater than 4 over 7.
So you should multiply like 2 over 7 or 2 times it, or 2 multiplied by 7.
You got it. And then just compare those numbers that you get. That's it. That's definitely an easy way to do it, right? Either method works. Method 2 doesn't give me that good of an understanding, right? I just have these two numbers. One of them is bigger. That's all I know. The other one gives me an understanding of what the equivalent is and then how much bigger it really is. So it's probably a little better for comparing more than two things. Method 2 is only really good for comparing two things. All right, let's try this one. Example 2. Which fraction is greater? I have 4 3/5 or 4 2/3. If we were just talking about these numbers and we looked on a number line, if I had the number 4 on a number line and the number 5 on a number line, I know that both of these numbers are somewhere in this range because the big number in front represents that we're right here at 4. And then it's plus 3/5. This one is 4 plus 2/3. Both of those fractions are less than 1. So my answer has to be somewhere between 4 and 5.
Yeah. So I missed the last question, but I like get the cross multiply. Then how'd you figure out like 14 and what's the denominator?
You don't know what the denominator is. That's why that method's not the best method. It gives you the numerators, and if those numerators are compared, then it'll always work out that the bigger numerator is the answer.
So just 14 is the answer?
Yep, because 14 is bigger than 12. Yeah.
So there's not a denominator?
No, not in that method, which is why I don't really like that method. I would rather do the other one, which I'm going to do again right now. But we see how both these numbers are in between 4 and 5? Because they're both 4 and then 2/3 or 4 and 3/5. So reality is, if I'm comparing these two numbers, the 4s kind of cancel each other out. And what I'm really asking myself is what's bigger, 3/5 or 2/3? You might know the answer. That's wonderful if you know the answer. I'm still going to show you the two methods. All right, the first method is to get those two things to have a common denominator and make them so that they're equivalent fractions on the bottom. Let's start with looking at these two values. I have 5 and 3. What's the lowest number they both could multiply to become?
15.
Yeah, they both could become 15, right? 5 times 3 is 15. 3 times 5 is 15. So when I'm comparing these things, I'm going to multiply the first one by 3, top and bottom. I'm going to multiply the second one by 5, top and bottom. And it gives me equivalent fractions. So the first one would become 9 over 15. The second one would become 10 over 15. And if we think about what a fraction is, it's breaking something into pieces, right? So if I have 9/15 versus 10/15, which one would be bigger? The 10/15 would be bigger. So the opening goes to the right. The way you would read that as 9/15 is less than 10/15. This symbol means less than. And you read math left to right, just like you would in an English book, right? So left to right, 9/15 is less than 10/15.
So why did we get rid of like the 4?
We got rid of the 4 because we knew they both started at 4, which was equivalent, and they were trying to figure out the decimal part that was bigger. So, for instance, like this is still 4 9/15ths, and this is 4 plus 10/15ths.
Oh, so the 4 is just like irrelevant.
They're irrelevant because it's the same starting point. It's like having this, like 4.2 versus 4.3. Right? We don't really care about the 4s because they balance out. But then we're just looking at the decimal values.
So if it's like 4 over 5, the one with 5 is automatically bigger.
Automatically, because the number started off bigger. Yeah. Unless for some reason the fraction is a bigger fraction than a decimal, which does happen, and we'll show you if that happens.
Okay.
That's method 1. Honestly, I think it's the best method because it gives you an understanding of what you have. Method 2 would say that you just take the fractions. We have 3 over 5. We have 2 over 3. And cross multiply. So if I multiply the 3 up there, and I multiply the 5 up here, I would have new numerators of 9 and 10. And then all you would need to do is figure out which numerator is bigger. It's like the same as part 1, but without the denominators. I would rather you do the denominators, in all honesty. But if you're struggling with doing denominators, this is a legitimate strategy that would work. 9 is less than 10. That means 3 over 5 is less than 2 over 3. Yep. Like that one. Yeah, and that works. And I know in like Foxtrot, that's how most of you guys' teachers would have done it, right? Cross multiply. Yeah. And that works. It's perfect. The problem is when you get more than 2 fractions. That's when you get into a bit of trouble, right? Because you can't cross multiply 3 fractions. You don't have enough spots, really. Okay, let's talk about negative numbers. We're going to talk about which fraction is greater. We have negative 5 over 6 or negative 7 over 8. I would like to get these to have a lowest common denominator. This one's a little trickier because we have 6 and we have 8. I'm going to skip count a little bit. So it's 6, 12, 18, 24, 30, and so on and so forth. Those are the multiples of 6. 8 is 8, 16, 24, 32, 40, and so on and so forth. And I realized that they both have a common number in 24. So 24 is the denominator that I'm trying to make them become. To make each number 24, how would I make the 6 into 24? Yeah. Yeah, times by 4. And we're going to do that to the top and the bottom. That means this fraction is equivalent to negative 20 over 24. That looks messy. I'm going to write it like this. Negative 20 over 24. That's a little bit better, hey? Now I'm going to look at negative 7 over 8. I want to get a common denominator of 24, which we agreed on. How do I get 8 to become 24?
Times 8.
8 times what would be 24?
8 times 2.
8 times 3. And the way that you know is by your skip counting, right? So that little right here, 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. That's how I know it's 3. And that would give me a fraction of negative 21 over 24. Okay. Comparing which one's greater. When comparing which one's greater, negatives can sometimes make things tricky. Right? If I have negative 20 24ths and negative 21 24ths, people are inclined to think that the 21's the bigger number, when in reality, it's the smaller number. And we're going to think about it as a number line. So if I had a number line, let's have the number 0 in the middle, 1, negative. The greater number on a number line is always the number to the right. So if you were to place these two numbers on a number line, we have negative 20 and negative 21. I'm going to count back negative 20. It's going to be like there, negative 20 over 24. And then if I went another negative 1, I would have negative 21 over 24. Right? Negatives are going to the left. So because 21 is bigger, I actually went further left because it was negative on the number line. So the bigger number in this case would be negative 20 over 24. You could write that however you want. I'm going to write it like this. Negative 20 over 24 is greater than negative 21 over 24. Which means, if we go back to our original question, negative 5 over 6 must be greater than negative 7 over 8. I'm not going to do method 2. Well, yeah, I'll do it because you can do it fast. Method 2 would say, don't worry about a common denominator. Just write your two things. You have negative 5 over 6, negative 7 over 8. And you're just going to cross multiply. Negative 5 times 8 is negative 40. Negative 7 times 6 is negative 42. Because these are negatives, 40 is the bigger number. Therefore, negative 5 over 6 is greater than negative 7 over 8. Yes, sir. Yeah. Either method works. I far more prefer the equivalent fraction way with the lowest common denominator.
Why do you control that?
Because converting to fractions is a skill that's going to be useful in the future. It also works for every question more efficiently. So like if we had 3 fractions, it's hard to cross multiply 3 fractions. Right? Like this little arrow crossing thing we do with 2 only works out so well. You technically can cross multiply more than 2 fractions. You just look messy. And the numbers would get really large. Lowest common denominator keeps it smaller. Also lets me compare things a little better. Like I know when I look at this, I actually know how much bigger one thing is than the other. Right? The one on the left is 1/24th bigger than the other one. When I look at this gives me no context. I don't know if that's 2 whole numbers bigger. I don't know if it's 2/5 bigger. I don't know if it's 2/50ths bigger. All I know is that one of them is bigger than the other. And I would rather have the context to know. All right. Some questions. I'll do the first. I'll do A, D, B, and E. Then I'm going to let you try C and F. And then we're going to talk about G, H, and I together. Okay, so let's start with A. If I looked at A and I wanted to compare those fractions, what I would want to do is get a common denominator. Looking at their denominators, 6 and 12, I could turn 6 into 12. So what I would do is I would multiply the one on the left by 2. Because that would give me 12 on the bottom, which means I would have 10 over 12. Now I can compare 10 over 12 to 9 over 12. Which one would be bigger? 10 over 12 is bigger. That means the arrow is that way. That means 5 over 6 is bigger than 9 over 12. If I look at B, if I want to get a common denominator, the common denominator between 5 and 10, or 5 and 2, would be 10. Therefore, I'm going to multiply this one by 2, this one by 5. To give me new fractions of 4 over 10 and 5 over 10. Those two fractions are easy to compare because they're both tenths. The bigger one would be 5 over 10. So the arrow would be opening up towards 5 over 10. If we look at D, so I'm going to skip over to the negative column there. I have negative 2 over 3 and negative 7 over 9. I can get a common denominator of 9. If I multiply the one on the left by 3, and I do it to the top and the bottom, this gives me a new answer of negative 6 over 9. That is something that I could compare to the other fraction. Because these are negatives, negative 7 over 9 is actually less than negative 6 over 9 because it's gone further to the left. Therefore, my arrow, when I'm doing my less than greater than, should be facing that way.
So the negative 6 over 9 is greater.
Yeah, negative 6 over 9 is greater than negative 7 over 9. Yep.
So the lowest number is greater.
Yep. When it's negatives.
Yeah.
Yeah. If you're looking at E, I want a common denominator. 5 and 4 both multiply to become 20. So I'm going to multiply this one by 4. This one by 5. Gives me two new fractions of negative 12 over 20, negative 15 over 20. Because the negative means I moved left on my number line, negative 15 has gone further to the left on my number line. That means negative 12 over 20 is actually the bigger number. I want you to try C and F on your own. Don't worry about the column on the right, G, H, and I. I'll do that one after. I'll do 2 examples and then show you one on your own. We're going to look at these 2. So if you look at C, 6 and 9, if you just multiplied by 6 and multiplied by 9, it works. But the lowest common denominator would be 18. 6 times 3 is 18. 9 times 2 is 18. Getting the lowest common denominator is usually the better way to go, especially for future math classes. So it becomes 3 over 18 and 4 over 18. That's easy for me to compare now. 4 over 18 is bigger than 3 over 18. That means 2 over 9 must be bigger than 1 over 6. If you don't remember how those signs work, it's like a little alligator, right, that opens its mouth towards the bigger thing. For F, the lowest common denominator would be 24. So you have to multiply 3 by 8 and 8 by 3. Giving me negative 8 over 24 and giving me negative 9 over 24. Because these are negatives, they moved left on the number line. So negative 9 went further left, so it's the smaller number. Meaning that negative 1/3 is actually bigger than negative 3/8. Awesome. Comparing these guys. These mixed fractions. I don't like mixed fractions. The trick that I showed you works as long as the fractions are always a smaller number on the top, bigger number on the bottom. So for instance, like G is 2 1/3. So I know it's 2 point something. That means it should be bigger than any fraction where the top number is smaller than the bottom number. Unfortunately, with this one, the bottom number is the smaller number. So what I would do to compare these things is I would convert either my improper fraction into a mixed fraction or my mixed fraction into an improper fraction, whatever you're more comfortable with. My guess, people are better at making the mixed fraction into an improper fraction. So what I'm going to do is I'm going to take this right here, 2 1/3, and I'm going to convert that. I'm just going to do it on the bottom of my page because I don't have a lot of room. The way we converted this was we took the bottom number, we multiplied it by 2, and then we add that number to the top. So 3 times 2 was 6, so I add 6 to that top number, and it becomes 7/3. We did a bunch of practice on that Monday or before Christmas. I can't remember. It's been a while. Might have been before Christmas. So you take the bottom number, you multiply by the big number, you get an answer, you add that to your numerator. What that does is it gives me two fractions. So instead of saying 2 1/3, I can say 7/3. And now I can compare the two fractions just like I did before. Right? Get a common denominator, figure out which one's bigger. The common denominator in this case would be multiplied by 4, multiplied by 3. That gives me 7, 4, 28 over 12. And over here it gives me 33 over 12. 33 is bigger than 28. That means 11 over 4 was bigger than 2 1/3. Yep. If you look at H, we don't need to worry about the fact that they're mixed fractions. The reason we don't need to worry about the fact that they're mixed fractions is because they both have a 1. And those things basically cancel each other out. They've both got -1 to the left. And then you just need to compare their fractions. -4 over 5 and -5 over 6. If you get a common denominator, good common denominator for those two is 30. So I would multiply the first one by 6 to give me -24 over 30. I'd multiply this one by 5 to give me -25 over 30. And now I know that the one on the left is greater than the one on the right because they're negatives, right? So it goes like that. If you look at I, you could do the same way we've done all of them, and that would be fantastic. Another way you could do I is by realizing what their decimal values would be, just approximate. So for instance, how many times does the number 7 divide into 17? 7, 14, and then 21. So it's 2 point something. If you look at the other fraction, how many times does 5 go into 16? 5, 10, 15, and then some extra. So this one's going to be 3 point something. So even though you might not know what it is, it's a little bit easier to figure it out just by kind of guesstimating their decimals. It also doesn't help that the first one's a negative. So the first one went left and the other one went right. So it's pretty easy just by their symbols to tell which one's the bigger one. Right, this is a -2. So the answer is definitely that -17/7 is the smaller one. The way things can get a little bit trickier is they can try to get you to compare decimals to fractions. To compare those things, you have two choices. Choice number one is to make both things a decimal. Choice number two is to make both things a fraction. It depends on the question on which way might be easier to go. So if I were to look at example number 5, I have a fraction versus a decimal, but the fraction is divided by 10. And I can convert divide by 10s really easily. This is what we did on Wednesday. So if I'm dividing by 10, all I do is I take the top number, which is 7. I give it a decimal place, 7 decimal. Divided by 10 means I move the decimal place over 1. This is the same thing as saying 0.7. Remember, if it was divided by 100, I would move the decimal place 2 to the left. Now, it's super easy to compare these decimals. The bigger one would be 0.7 is bigger than 0.65. So therefore, 7.10 is greater than 0.65. That's the easier way to do that one. No question about it. You could try to turn that decimal into a fraction and then reduce that fraction so that it's equivalent. But that's probably harder, especially for that one. Nope, looks good to me. So if you look at question 6, it says which is greater. Now we have a mixed fraction versus a decimal. I still think it's easier to change the fraction into a decimal in this one because it's divided by 5. However, there is something that I'd want to deal with first. And that thing I'd want to deal with is realizing that the numerator is bigger than the denominator. So if I have 7 divided by 5, how many times could 5 go into 7? That's what would be left over. If you're counting by 5s, how many times can you get before you're bigger than 7? Once, right? That means there's going to be 1 whole and then 2 left over out of 5. So if I had 2 and 7/5, that's the same thing as saying 1 plus 2 is 3 and then 2/5. Right? I took that fraction, I turned it into 1 and 2 over 5, and then I added these numbers right here to get 3. Took the fraction, 7 over 5. I figured out how many times 5 goes into 7. It goes in once. If I take 5 away from 7, I'm left with 2, and it's fifths. Right? That's how I'm doing that fraction into a mixed fraction. And then I can just add the big numbers. At that point, if I have 3 and 2/5, this is the same thing as saying 3 point whatever decimal that fraction is. I'll use a different color than green. Right, that's what that means. 3 wholes point something. 2 over 5 we know is 0.4. That means this is 3.4. So by converting that improper / mixed fraction, it's kind of both, to be 3.4, we can now compare the two. They're actually equal to each other. So 2 7/5 equals 3.4. Neither one is greater. That one's a hard one. If we look at example number 7, if I'm comparing these, it's probably easier to go to a decimal. This means -5 point. The fraction beside it is going to be the decimal that comes after. 3/8 is not an easy one to convert. If you remember from Wednesday, we said 3/8 is the same thing as saying 2/8 plus 1/8. And those were decimal values we knew. 2/8 was 0.25. 1/8 was 0.125. That means 3/8 is 0.375. So you're going to have to mix our two lessons together to be able to figure out one like that. I'm now asking myself which number is bigger, -5.375 or -5.4? Because they're negatives, -5.4 has gone further left. Therefore, -5.375 is greater than -5.4. Another hard one, right? The 8s are very hard.
What about the 25s?
Oh, example 8? Example 8 is tricky. So, we talked about square roots a little bit. Not in a long time, hey? Beginning of the year. Square roots. This symbol right here. Does anyone remember what that symbol means? Square root? Yeah, you're trying to find a number that times itself would equal something. So on the side, like we're just going to have a little side thing here. If I had the square root of 25, what that means is what number, that's what the square root is saying, what number times itself would equal 25? So for instance, 2 times 2 is 4. 5 times 5 is 25. So the square root of 25 is 5. That's what a square root is. It's taking the number underneath and saying what number times itself would equal that number underneath. Now for fractions, that's like near impossible. So when you look at this question here and it says, what's the square root of 9 over 25? That means what fraction times itself would be 9 over 25? That's very challenging. So there's actually a rule about square roots that we're going to use. And that rule is that a square root can be broken up into 2 square roots. So instead of saying the square root of 9 over 25, we could say square root of 9 divided by square root of 25. And that's easier to tackle. On the top, square root of 9, that means what number times itself would equal 9? Yeah, 3 times 3 equals 9. Therefore, the square root of 9 is 3. On the bottom, the square root of 25, Drake already answered for us. Right? What number times itself equals 25? 5. That means the square root of 9 over 25 equals 3 over 5. 3 over 5 is a decimal, we know. 3 over 5 is 0.6. And now I want to compare which number is bigger, 0.6 with a line over it or 0.6? Yeah.
0.6.
Yeah, why is 0.6 with a line over it bigger? Like Keely's got.
Because 6
Yeah, the line over it means keep going, right? So that's really 0.666666666, often to infinity. That means that's the bigger number. So 0.6 is less than 0.6 with a line over it. No, that's for our notes. So this is the same thing as saying root 9 over root 25. Same thing as saying 3 over 25, which equals 0.6. You eat a lot of things, doesn't mean it's good for you. All right. Few questions here that we'll do together. So you look at A. We have 0.6 compared to 2 over 3. We know what 2 over 3 equals. That's when we practice on Wednesday. 2 over 3 is the same thing as 0.6 repeated. That means 2 over 3 is the bigger number. If we look at B, actually, no, we're going to look at C first. We're going to go to the right. If you look at C, I would convert 4 over 5 to be a decimal. We know that 4 over 5 is 0.8. That's one that we had memorized. 0.875 is greater than 0.8. If we look at E, we have negative 4.7, and then we have negative 3 and 7/4. My first thing I'd want to do is convert 7/4. 7/4, 4 can go into 7 once. And then I would be left with 3/4. So instead of saying negative 3 and 7/4, that's the same thing as saying negative 4 and 3/4. Then you can convert that into a decimal. The first part, the big number, means you have negative 4 point. The 3 over 4 is what comes after the decimal. That would be 7/5, right? 3/4 is 0.75. Because these are negatives, this one is actually bigger, the negative 4 over 7, negative 4.7. That's one of the harder ones. Yeah, I know. Well, we're on the second part of this now, so it does get a little harder. Yes. Yep. Okay, if you look at B, to do B, I would deal with the square root. The square root of 49 over 16 is the same thing as saying square root 49 divided by square root 16. Then I would ask myself, what number times itself equals 49? Yeah, you got it. 7 times 7 is 49. That means the square root of 49 is 7. What number times itself equals 16? 4. You guys got it. So instead of saying square root 49 over 16, I have 7 over 4. Four goes into 7 one time, and then I'm left with 3 over 4. That means it's the same thing as 1.75. Where the 1 matches up here, the 3 over 4 matches up here. That means these two things are equal. If you look at D, if I do it really quickly, the square root of 81 is 9, so I have negative 9. Square root of 4 is 2. I have 9 over 2. 9 over 2. 2 goes in 2, 4, 6, 8. It goes in 4 times, so I have negative 4. And then 1 over 2 left. That's the same thing as a negative 4.5. If I take the other one, I have 8 goes into 13 once, so I have negative 2 instead of negative 1 out front. And I would be left with 5 over 8. I don't even need to convert this anymore because I can just look at the big number. I have negative 4 point something, negative 2 point something. Negative 4 is definitely going to be smaller. So that means my arrow would go like that. The last one. The square root of 1. So what times itself equals 1 would be 1. 1 times 1 is 1. So the square root of 1 is 1. For 64, two numbers that multiply that are the same to be 64 would be 8. 8 times 8 is 64. This one, however, does not work out very well if you tried to square root it. The square root of 3, crazy number. Square root of 300, another crazy number. So instead, what I'm going to do is I'm going to reduce that fraction before I square root it. 3 and 300 both divide by 3 to become 1 over 100. That one I can do. The square root of 1 is 1. The square root of 10, the square root of 100 is 10. And now I can compare those two things. Negative 1/8 has gone further to the left than negative 1/10. Therefore, negative 1/10 is the bigger number. If you did it as a decimal, it's 0.175 versus negative 0.1. Those last examples are challenging. So if it was kind of like, whoa, I get that. Placing numbers on a number line. You're just going to try to do some estimation. So if you look at 3 over 2, 3 over 2, how many times can 2 go into 3? 1 point something. If you look at your number line, the only number that's in between 1 and 2 is D. So I don't actually need to figure out the whole decimal. I just need to figure out the front number. If I look at C, I'm going to do the same trick. How many times does 5 go into 14? 2 times, right? 5, 10, so it goes in twice, and then it's decimal something. If I look up at my number line, there's only one number that's 2 point something. It's E. If I look at B, the negative 0.7. Negative means I went to the left 0.7. Looking up at the number line, the only thing I went to the left and didn't get past negative 1 is C. If you look at D, D is negative 1 point something. It's negative 1 and 1/3, but negative 1 point something. Looking up at your number line, that's B. And by process of elimination, E must be A. So when you're doing those number lines, check to see if they're spread out like that. If they're spread out like that, you can just rip right through it. You don't even need to do all the conversions. You can just do the first whole number and then estimate the rest. The last question, I just want to talk about what arranged in ascending order means, and then I'll do it really quickly for you. Ascending means you want to go up. It's the same thing as saying the smallest to biggest. Mathematically, we say least to greatest. If you ask me what ascending means on a test, I cannot tell you. So you need to know ascending means going up, smallest to biggest, least to greatest. If you want to do that, start with your negatives, right? Negatives are always the least. So I have negative 1 point something, negative 0.1, and then I have negative 1. So without even having to calculate those, negative 1 point something is the smallest, so negative 1 2/3. Then negative 1 is going to be smaller than negative 0.1 and negative 0.1. Then I'm going to try to sort these numbers. I have 1 5/8, 1.9, and this thing, which is going to be 6/4. You're probably going to have to convert all those into decimals to be able to compare them accurately. 1 5/8 becomes 1.625. 6/4 becomes 1.5. If I'm going from least to greatest, that means 1.9 is the next smallest. Sorry. That means the square root of 36/16. Then it would be 1 5/8. Then it would be 1.9. We're not going to focus too much on the conversions. I'm more worried about you understanding the word ascending. I know you can do the converting. We just spent like half an hour doing it.